Hello again and welcome. In this video, you'll be learning how to perform descriptive statistics using Excel and also how to use the data analysis toolpack. I am Esther Baima, a senior data associate here at Analytics. Let's jump right in. So what is descriptive statistics? Descriptive statistics, they are numbers that are used to summarize and describe your entire data set. So I try to picture a funnel. You have your data set and then you pass it through the funnel. It gives you numbers, it gives you summaries that you can use to describe your entire data. So moving forward, types of data that we consider when working with statistics. First thing, your population data. You can see clearly this data refers to the entire set of individuals or groups or collections that have a particular property or characteristic. So let's take, for example, if you want to know the total number of persons that are working, that's working class citizens from the UK, you know that you have to get every single individual, both in the UK and both outside, that are currently of age and are working. That's classified as working class citizens. So for your population data, it refers to the entire set. So you have to go and calculate and find out every single individual that belongs to this group. But then again, this is practically impossible because you will not be able to reach out to persons that are in other countries, and it will cost you a lot of money and a lot of resources. That is why we have your sample data. So in order to know the amount of persons that are working class, instead of you practically impossibly trying to get the total population, you can decide to take samples. From this region, let's get a sample. From another region, let's get a sample of citizens that are working there. And then at the end, you can use that sample to infer and create a summary for your entire population. So that is why your sample data is very, very important. And this is just a pictorial representation of your population and your sample data. And another important thing is your sample has to be representative. It should be taken at random. It should accurately represent every working class citizen, all the regions in the UK. So moving forward, the population data is denoted with N, and the numbers obtained here are called parameters. While your sample data is denoted with a small letter n, the numbers obtained using your sample are called statistics. So because it is practically impossible to gather all of the entire population, that is why we have your sample data. And as a data scientist, you will most likely be working with your sample data. So what are the measures that we have under descriptive statistics? There are two. You have your measures of central tendency, and then you have your measures of dispersion. Measures of central tendency. What exactly is this measure? It's a measure of central tendency is a statistical value that represents a center or central location of your data. So remember a funnel scenario where you have your data set and then you pass it into a funnel, and then it gives you numbers that you can use to summarize or describe your data set. That is where your measure of central tendency comes into place. So you can see clearly, it provides a way to summarize and describe the distribution of your data. And then we have three measures: your mean, your median, and your mode. So what exactly is your mean? I know we did this during your preschool education, but I want us to really understand what our mean is. So your mean, it is simply the average of your data set. We'll be going to Excel and then having like a practical overview of this. It's just as if you have numbers from, let's say, 1 to 5, and then you take the average of the entire numbers from 1, 2, 3, 4 divided by, okay, you add everything together and then divide it by the frequency. That gives you your mean. Simple. Now moving forward to your median. Your median is the midpoint of your data set when it is arranged in ascending or descending order. So going back to our numbers from 1 to 5, if you arrange that in either ascending or descending order, and then you just pick out the middle, that is number 3. So number 3 is the middle and thus the median of your data set. As I mentioned before, we'll be going over to Excel to have like a practical overview of this. This is just the definition. So finally, what is your mode? The mode is the value that occurs frequently in your data. A data set can have one mode or it can be multimodal. So depending on the particular column feature that you're working on. So these are the measures of central tendency. You have your mean, you have your median, and you have your mode. They are basically just used to summarize your entire data set and describe the distribution of your data. So moving forward, your measures of variability. These are also called your measures of dispersion and then your measures of spread. What it does is it measures how far apart your data is from, let's say, the center of your distribution. Considering your mean in this scenario, you have different data points and then you've calculated the mean. How far apart are your data points from your mean? So you can see it tells the extent to which the data points are spread or clustered together. So moving forward, we'll be considering three measures of variability here. You have your range. The range is the spread of your data from the lowest to the highest value in the distribution. So you have a data set. You get the largest value, that's your maximum value. And then you get your minimum value, that is the smallest value. Your range basically is you subtracting your minimum value from your maximum value. As I mentioned, we'll have an overview in Excel, so you'll see how this is done. And one thing to take note of is if you have a very large range, that means that is telling you that the values you have in your data sets, the observations are very wide apart. They are spread apart from each other compared to when you have a lower range. So moving forward, what is variance? Variance measures the average squared deviation of each data point from the mean. So you have a mean, you have your mean value, a single value. Then you have other values, other data points in your distribution. What your variance does is, what is the difference between my mean and then the data points that I have? So it's going to calculate that and then square that and get the average of that value as your variance. So moving forward, what is your standard deviation? You notice that you squared your variance. Your standard deviation just brings back your variance to the original scale of your data. You can see it is a measure of the dispersion or spread of the data points around the mean. It is the same unit as your original data set. So you notice that you squared your variance, so that magnifies the value. But what your standard deviation does is it brings that value back to the scale of your data. So you can clearly see that if I have a very high standard deviation, that means that, oh, my values are far apart. They're spread apart from each other compared to if I have a very small standard deviation. So descriptive statistics, you have your measures, you have population and then sample data. Then you have your measures of central tendency that are used to summarize your data and give you values that you can describe your data with. And then you have your measures of variability. That's your measures of spread or dispersion that tell you how spread apart, how far apart are your values around the center of the distribution. It tells you the extent to which all data points are spread or clustered around the mean. So we'll be going over to Excel right about now, and you can see how this is made simple and easy using the data analysis toolbar. So let's jump right in. Now, this is Excel, and let's say you work for this organization and then you've been given the monthly income, that's the salaries of employees you have in this organization, and you've been requested to perform your summary statistics and give us an overview of what exactly, can you give us an idea of what is happening, or can you give us a summary statistics of your monthly income? All you have to do is to use the data analysis toolbar. So this is a feature in Excel that makes life less stressful for you as a professional. So all I have to do is come to my data tab. So I will just turn off my video so this can be clear enough for everyone. So come to your data tab, then navigate to your analyze group, and you see your data analysis here. So if this is not here, all you have to do is click on files, come to options, then navigate to add-ins, then come to manage and ensure that you have your Excel add-ins highlighted, then click on go. So you just have to come here and then tick your data analysis toolpack and then click on OK. So you have your data analysis toolpack installed in your data tab. Okay, so you can just go over this again if it is still unclear. So moving forward, I want to get my summary statistics for my monthly income. All I have to do, click on my data analysis toolpack. Then I'm going to come here and click on Descriptive Statistics and then click on OK. So I have to specify my input range. And you can see our monthly income is in columns, not in rows. So I have to click on group by columns. Then labels. If you are going to highlight the label, you see I clicked on this label, then you have to come back here and tick label. So we're just going to do this right about now. I'm going to highlight this to clear it out. Then input range, this is my input range. Control Shift down arrow to highlight it. Then I'm going to take group by columns and labels in first row because I highlighted the label. Then for my output range, that's where do you want your summary statistic to be? I do not want it on the new worksheet, so I'm just going to click on output range, then Control Shift up arrow to go back up. So I would prefer my response, that's my summary statistics here. Then I want my summary statistics, so I'm going to click on this and then click on OK. So this gets computed for you. So I think to make this presentable, I'm just going to come to my View tab and untick my grid lines. And let's create a border around this. Come to my Home tab and then click on Tick Borders. So you can see. So you can clearly see your mean, your standard error, your median, your mode, your standard deviation, your standard variance, kurtosis, skewness, range, your maximum, your minimum value, your sum, and then your count. So going back to the scenario that we had for 1 to 5 numbers, that's 1, 2. So I'm just going to highlight this and then drag it down till I have 5. If I want to calculate the mean of this, it's just to come here, click on equal to my average of my future, close the bracket and then enter. So instead of you doing this individually for your mean, doing this for your mode and doing this for your median, and then also coming back to calculate your standard deviation, your variance, what your data analysis toolpack does for you, it computes everything at a go, and then you're good to go. So what does your mean do? It basically just calculates the average of your entire data set. Then for your standard error, this tells you what is the distance or what is the deviation between the sample mean and then your population mean. Your median, I mentioned, you have to sort your data from the highest, from either in ascending order or in descending order, and get the center, the middle of your data. So all I have to do is come here, equal to my median, and I'm going to highlight this and close this, enter. So even if, let's say, I remove 5 from here, let me delete this, and then come back here and include a 5. Then I want to compute my median as equal to median of this. Highlight this, then enter. So you'll notice that we get back 3. Why? Because Excel will sort your data from in either ascending or descending order and just go and pick out the middle value and you are good to go. So I'm just going to go back. Yes, so this is where we are. So you've gotten your mean, your standard error, your median, your mode. Now, standard deviation. Let's have a scenario here. This is a scale. And a standard deviation is 4,700 and roughly $708. And let's say this is around here. Then you have other observations, other monthly income. You have 200, you have roughly $290, $3,468. So What's your variance does, first of all, is what is the distance between each of your data points and the mean? Calculate it. Get it for all of the data points that I have. Now, this value that you have gotten, square it and find me the average. That is what your variance does. So it's going to look at your mean value, then calculate what is the average deviation of each of the individual values from our mean value. This is our mean. That is what your variance does. But your standard deviation, you notice that you squared your variance. Your standard deviation now brings your data, brings your variance back to the scale of your data set. You notice our value here for our variance is extremely large. So what your standard deviation does is it brings your variance back to the original units of your data set. So, and I mentioned, if you have a smaller variance, or rather a smaller deviation, that means your values are clustered around the mean. But then if you have a very large standard deviation, it means that, oh, the distance between your mean and your data points are very, very far apart. So we'll be explaining kurtosis and skewness using a histogram. But from what we mentioned, your range is the difference between your maximum value and then your minimum value, and then you have a sum. This basically just tells you the sum of that's the total monthly income. Then you have the count. How many employees are listed in this data set that I have? So I'm just going to erase this. I really do not need it again. I want to best believe that we can now use our data analysis toolpack and get some statistics. So moving forward, let's explain kurtosis and skewness. So kurtosis basically just measures the sharpness of your peak, while skewness measures the symmetry. So symmetry is just when you divide your data, when you have a distribution and then you divide it into two, both sides are mirror images of each other. This might sound gibberish, but let's insert our histogram and we'll clearly see how this happens. So if I just highlight my data, or rather, let me come to my data tab and come to my data analysis toolpack. And I'll scroll down till I find histogram. And I'm going to click on OK. So it's going to prompt you, what is your input range? So I'm going to come here, Control Shift down arrow to highlight this. Then I don't have a bin range and my labels. I'm going to take it. If you recall, I highlighted my monthly income. Then my output range, where do I want my results to be? So I'm just going to Control Shift to go back to the top. Then I'm going to select here. Then I want my outputs. I want my chart outputs also. So I'm going to click on OK. So this gives you your bin range and then your frequency. So you can clearly see the histogram detailed here. But then again, this is extremely clumsy and might not really be clear, because what this is telling you is that, oh, for your bin, for persons earning from $0 to $1,009, we just have one. Moving to the next one, for persons earning from $1,009 to $1,508, we have 18 employees that are earning within these buckets, within this salary range. So that is what your bin computes for you. But now I want to specify my own salary range. I want to specify that, oh, I want to see persons earning from, let's say, $1,000 to $5,000 as one category, as level 1 monthly income. Then level 2, you have the next category, $5,000 to $10,000, that's level 2. So I want to indicate my bins. I want to indicate my group. So I'm just going to delete this. So I'm going to delete this. And there's a formula for calculating your interval. You notice, I want to specify that my salary range comes from this value to another value. Let's say from $1,000 to $500. So you have to specify that. And I want 5, or rather in this scenario, I want 10 groups. So I'm going to specify this as my number of groups. I'm going to include this as 10. Then just follow me. What is your maximum value? I have to come back here, equal to my max. Then I'm going to highlight this, Control Shift down arrow and enter. Then what is the minimum value of your data? So this is equal to my mean. Then Control Shift down arrow, enter. Now I want to calculate my interval. You notice if I have a salary range, hypothetically from $1,000 to $5,000, that means that in that scenario, my interval is $5,000. But now I have 10 groups, I have my minimum, I have my maximum value. I want to calculate my interval so I can know if I come back here and I specify my lower bound. Then my upper bound. And I want 10 groups. You notice I specified 10 groups. So 1, 2. I'm just going to highlight this and drag it down till I get to 10. What I want to do is I want to specify 10 groups, 10 levels of salary income. So this is level 1 monthly income, level 2 monthly income, level 3 monthly income. And I want to visualize this in my histogram to show the distribution of the monthly income. So let's calculate our interval. You notice the formula for calculating your interval is your maximum minus your minimum divided by the number of groups you specify. So if you want to go ahead and find out 20 levels of salary, 20 levels of monthly income, you can do that. But me, I just want to have level 1 to level 10. So all I'm going to do is equal to, I'm going to include a bracket, my maximum minus my minimum value divided by my number of groups. I'm going to enter. So this gives me my interval. This gives me what exactly am I going to add to get my range to. Now I want to specify my range and I want to start from my minimum value because I want to see a scenario whereby if I have my lower bound as $1,009, this is the minimum value in your data, in your monthly income range that we have over here. Okay, so my upper bound, to get my first upper bound, to get, let's say, if we're using $1,000 to $5,000, 1,000 is your lower bound, and then 5,000 is your upper bound. To get your upper bound, this will just be equal to this plus my interval. And I have to lock this interval. I have to ensure that it doesn't move out of this position, because if I click on enter and I drag this down, you notice I'm getting 0. You notice I'm getting 0, but I do not want this. So I have to come back here and then lock this in position by imputing a $sign. So you're telling Excel, do not move from this cell. Keep it fixed, keep it in position. So I'm going to click on enter. So the same way we had $1,000 to $5,000 as a group, as a range, that's the same way we've gotten $1,009 to $2,908. So I'm going to get my second level now. So I'm just going to do equal to of this. Then to get my upper bound, that will be equal to this plus my interval again. So I'm going to lock this by using my F4, then enter. So instead of going through the stress of manually typing this, I can highlight this, then fill it to the bottom. So you can clearly see that, oh, in level 1, I've gotten my lower bound and my upper bound. So level 1, the salary range is from $1,009 to $2,908. For level 2, from $2,908 to $4,807. So that is what this does for you. That's what your interval does for you. But what my end goal now is I want to go to my monthly income and find out in this level 1 salary range, in this level 1 monthly income, how many employees are within this range? Moving to level 2. You're telling Excel, you want to tell Excel, go to my data, go to my monthly income, and then count how many of my employees are within this range. So you've successfully calculated your lower bound and then your upper bound. And that is your bucket. That is your range. You're saying, oh, from this level, from this amount to this amount, how many employees are within this range? So let's insert our histogram. We're coming back to our data tab and then data analysis. So you have to scroll down. Okay, you know, we used a histogram before. So I'm just going to click on it, then click on, okay. This is our input range. That is our monthly income. Then your bin range. Note, Excel works with your upper bound. So all I have to do is come back here and then highlight my upper bound. Then my output range, this is where I want my values to be. And I want to see my chart output because I want to see my histogram. So I'm going to click on, okay. So you notice, so, you know, initially, the first time we did this, we did not specify our bound, our upper bound. We did not specify our buckets. But in this scenario now, Excel is now telling you that in this first salary level, in this first monthly income level, we have 365 employees that are within this range. And you can clearly see from our histogram that for each of the bounds, for each of the salary levels, you can see the corresponding number of employees that we have here. And then finally, moving on to skewness and then kurtosis. You know, I mentioned, if you divide your distribution into two, if you close it and then it's exactly equal, that means that your skewness is 0. But in this scenario, your skewness measures your asymmetry, right? So that means if you close your distribution and it doesn't give you a mirror image of both sides. So if we close this now, if we were to take this histogram and then fold it into two, you'll clearly see that both sides are not a mirror image of each other. And you notice that you have a long tail to the right side. So that means that this, your histogram, is right skewed. And for you to have a right skewed, it has to be greater. It has to be on the positive side. It has to be greater than 0. So you have a range. Let's say you have a skewness of 0 means that your distribution is exactly symmetrical. That means you do not have outliers or you do not have, okay, extreme or person earning extremely large monthly income in your data. But then if you have like a skewness of ranging from -1 to 1, that's fairly skewed. So it will either fall into your positively skewed, that's your right skewed, or your negative skewed. So if I come to my draw tab and try to trace this out, you'll notice you have a longer tail to the right. So that is telling, and if you come back to your summary statistics, it's telling you that your skewness is 1.36. This tells you that, oh, that means this is skewed to the right. Then what does your kurtosis do? Your kurtosis measures the peak of your data. All right, so it tells you that, oh, is my peak extremely sharp, or is it spread, or is it flat? So if you come to this 0 now, you can see the peak. You can see how sharp this is. You can see how sharp this is. And you can clearly see that your kurtosis is greater than 1. So you have a sharp peak when your kurtosis is greater than 0. But when your kurtosis is 0, that means that that is normal. That's the normal distribution. But for your kurtosis less than 0, it means that the peak of your distribution is extremely flat. So I hope that we have learned a lot in this video, and ensure you subscribe to our channel and then like this video, and we'll be coming up with more updates for you to learn. So this is how you can use the data analysis toolpath to create your summary statistics at a go, and then you're good to go. So cheers and see you in our next video.